So the first thing we have here is x arrow positive or negative infinity. So notice that this is different. Okay, 2.3, 2.4, x approaches a number. Today, x is approaching positive or negative infinity. When x is going to positive or negative infinity, this puts us in a different category called end behavior. The part of end behavior that you may remember because you were in school when you learned it is polynomials. Okay? Polynomials have end behavior. And the polynomial end behavior was a little chart trying to tell you which direction your arrows would go. Okay, this little chart has to do with the degree and the leading coefficient. So this parabola column is an even degree. This cubic graph is an odd degree. Okay, I'm starting with something that you heard in Algebra 2, end behavior, polynomials. You probably repeated it for like a half a day in pre-calc, maybe, okay? Now the first row is for a positive leading coefficient, and the bottom row is for negative. It looks like it's opening down. Okay, when you're in the end behavior category, you always look at the leading term. Leading term. So right now we're building up from what it looked like in Algebra 2 to what it's going to look like when we answer the questions, okay? So we're going to look at the leading term. Let's say, for example, okay, y equals, okay. I got to start simple so that it makes sense when we get to the harder explanations. Okay. The limit as x approaches positive infinity of, I don't feel like rewriting it, I'm just going to say y, which is the equation that I gave you here. Okay, first thing I notice is that x is going to positive or negative infinity. So that puts me in the end behavior category, and I need to look at the leading term. The leading term is the piece that has the highest power. I'm just going to highlight it. And I'm going to go over here to my little chart. Even, positive. So it's the top left picture. I'm just going to make a little note to myself. This is a top left picture. Because we all know that a x squared is a parabola and it's positive, so it's opening up. And I'm going to look at the right side. That's this arrow, because that's the right side. X to positive infinity is the right side. This y value is pointing up. A lot of thinking, not a lot of writing to answer the question. Okay, the limit as x approaches negative infinity. Okay, negative infinity is the left side. Put your mask on. Okay, that happens to also be up. Now, in pre-calc or Algebra 2, you didn't actually write limit statements when you did end behavior. This would have looked like this. It was just the arrows. That's what it looked like when you saw it before. It was just the arrows pointing at the values. Okay? We're going to write it as a limit statement. All right, so let's do a second one. Okay? We're just priming our brains with the right vocab. So let's say g of x equals negative x to the 7th minus 3x. Sure. There you go. We're going to do the same thing. We'll do the right side and we'll do the left side. The limit x approaches positive infinity.
That's a 7.
That is a 7. There you go. We'll do the limit x approaches negative infinity. Okay. So I'm going up here. So x is approaching positive and negative infinity. So that puts me in the end behavior category, which is asking me to look at the leading terms. So I'm going to highlight my leading term, which includes the sign in front. Okay, so I checked my chart. It's a negative odd. Okay, the number in front is negative and the degree is odd. So that means that this bottom right picture is what the arrows are doing. So it goes, whoa. Okay. This is just like a shortcut picture of what the arrows would do on the graph. Okay, so now the right side is the right arrow. The right arrow is pointing down. Negative infinity. Okay. The right arrow, or the left arrow, negative infinity, is pointing up. Okay. Okay.
Should we start a new page for this?
Nah. Okay. Part B. We are going to look at, okay, we are still doing positive or negative, x is still going to positive or negative infinity. Okay. Which means we are still in this end behavior category, which means we're looking at the arrows. Okay. This one is actually going to be the top-heavy category. Okay. Top-heavy means that you have a fraction, okay? So this is where the numerator degree is bigger than the denominator degree. Okay, so we know that we're looking at end behavior, okay? This is going to be a top-heavy category. Now, when I'm looking at end behavior, I'm looking at the leading terms. In this particular case, we're looking at the ratio of leading terms because we happen to have one on the top and one on the bottom. Because we have two leading terms, one in the top of the fraction, one in the bottom. So here is our example. Okay. Yeah, I probably could have flipped my page, but oh well. Okay. The limit as x approaches positive infinity. Okay. X cubed minus x plus 1 over 3 minus x squared. Okay. End behavior. Leading terms, right? Every time you're in the end behavior category, you have to look at the leading terms. So I'm going to highlight my leading terms. Include the sign. See that negative is included with the x squared in the bottom. What do my leading terms reduce to? Yes? Negative x. Okay. Negative x. This is kind of like my scratch work here. X cubed over negative x squared equals negative x. What picture goes with negative x? This one. This one. Okay, that's your end behavior, guys. It just comes down to the polynomial thing that you've learned already. Now we're just putting a little fraction up there. So we have to look at the leading term of the top and the bottom because you have a polynomial on the top and a polynomial on the bottom. So you have to put them together. So my answer, okay, I am looking at the right side, which is that arrow, which is pointing down. Lots of talking to explain it. Not a lot of writing to answer it. Okay. Okay, we ready? I'm just gonna do maybe one more example here. Two. Okay, so example 2. The limit as x approaches negative infinity of 4 plus 2x cubed over 1 minus x. Okay, scratch work. Okay. First thing I see is that x is going to an infinity. That tells me that I'm thinking about end behavior. Okay. End behavior tells me that I need to figure out what the leading term is and compare them because I have 2 leading terms. One on the top and one on the bottom. Right? End behavior means you have to look at leading terms. So I'm going to come over here and I'm going to reduce my leading terms. You're more than welcome to reduce in your head, right? I'm just writing it so you know the steps that I'm following. Okay. We have 4 pictures. Pick one that matches negative 2x squared. Right? You can do that. You just picked it out. Okay, now I'm ready to answer the question. Okay, so I'm looking at x to negative infinity. That's the left-hand arrow. And so the answer is negative infinity. Okay, part C. X is still gonna go to positive or negative infinity. All right. And this time, instead of being top heavy, this is going to be balanced. Maybe those words sound vaguely familiar. Balanced, which means the numerator and the denominator degree are the same. Okay, denominator. The degree of the top and the bottom are the same. Okay. So once I decide that I'm right, positive or negative infinity, I'm still in this end behavior category. Okay, end behavior. But end behavior is like the big topic. This actually turns into horizontal asymptote. Okay. That's all right, we can do it. Horizontal asymptotes. We have one new picture. Okay? So we've got our chart here and we've got arrows. Okay? We have horizontal asymptote now, which means that my arrow is going to come down to this horizontal line. That's end behavior. Okay? It's not up or down like we just did. It's leveling out at this horizontal line. I can spell that out. Horizontal asymptote. Not a vertical asymptote like last class. This one's going to be a horizontal asymptote. Okay, so we are still going to look at the leading terms, right? We're still in the end behavior category, which means we are still going to look at the leading terms. And then we'll see what happens. Okay. Here we go. Example. Okay. The limit as x approaches positive infinity of okay, 3x squared minus 5 over x squared plus 1. Okay. They're the same. Okay. X is going to positive infinity. I'm in the end behavior category. The numerator degree and the denominator degree happen to be the same. Okay, so I'm going to reduce over here. Okay. Right? I know I'm in the end behavior category. Right? I got it. I'm in end behavior. End behavior means I look at leading terms. Okay, the leading terms are, and they reduce to 3. All right, guys, what does y equals 3 look like? A horizontal line. So it's a horizontal asymptote, right? It used to be this, whatever. Now it went like this. That's it. It's just a number. It's a horizontal line. So it's not slanted. It's just horizontal. So the answer here is 3. Yeah, I started with the hardest examples because you're freshest. Okay. Now, what does that mean graphically? It means that the horizontal asymptote is y equals 3. You know how we identified graphically holes and points and vertical asymptotes? This is a horizontal asymptote at y equals 3. Okay. Second example. They get faster because they get easier. Okay. The limit as x approaches negative infinity, 5 minus x cubed over 3x cubed plus 4x. Okay. Okay. I know x is going to negative infinity, so I'm in the end behavior category, which means that I look at the leading terms. Okay, so I'm going to highlight leading terms. Okay. And I don't feel like reducing in my head, so I'm just going to do it over here. Whoop. Levels out to y equals minus 1/3. So this is a horizontal asymptote at y equals. Notice in infinities right before, that wasn't a horizontal asymptote. Okay, we're going to do the last category before we do a little bit of practice, and then we'll be done. Okay. D. Okay, we are still looking at x going to positive or negative infinity. Remember, that is not x approaching a number like our last two sections. Positive or negative infinity. This time we're going to be in the bottom heavy category. Okay, that means that the denominator degree is bigger than the numerator degree. Okay. So I'm still doing end behavior. End behavior. And this particular category is going to give me a horizontal asymptote. Okay? We are still going to look at the leading terms. Okay? But I'm going to do an example here, okay, before we get to the result. Okay, so let's say that f of x equals 1 over x. We're just going to go 1 over x. I want to answer these two questions. The limit as x goes to positive infinity, and the limit as x goes to negative infinity. Bottom heavy is a little bit special, right? Top heavy is a little bit special. Bottom heavy is a little bit special also. Notice here that as x goes to positive infinity, okay, 1 over positive infinity. Now, you don't really plug infinity in, okay? But what is 1 over 1 pizza divided into infinite number of slices? How big is each slice? Yeah? Really, really close to 0. Okay? Bottom heavy. The denominator is giant compared to the numerator. 1 divided by 1,000,000 is 0.0000, a couple more zeros, 1. Really, really small. And so the answer to this limit statement is 0. Okay, same thing. If I kind of fuzzy plug in infinity, because you don't really plug in infinity, but I can think about it. What happens when I do 1 divided by negative infinity? Basically 0. 0 is not positive or negative. It's very, very, very close to 0. So bottom heavy is kind of special where the answer is always 0. right? It's not like the coefficients don't really matter. It's just always 0, okay? So the horizontal asymptote is y equals 0. This is explaining why it's 0. This works for any category or anything that is bottom heavy. So let's do our examples and see what that looks like. There we go. As x approaches negative infinity, minus x plus 4x squared x cubed minus 8. Okay. Not a lot of work. Here we go. X is going to negative infinity. I'm going through my little flow chart in my head. X is not a number. X is infinity. So this is end behavior. End behavior takes me to the leading terms. Okay, so I'm going to put my leading terms out here. Maybe I forget what category I'm in, right? Bottom heavy, top heavy, whatever. Okay, I check my terms out. And it reduces, oh, now I remember, bottom heavy, 4 over x. That's bottom heavy. That means the answer, okay, you can even think about it, okay? What happens if you plug in negative infinity? Basically 0. That is what happens. What does that mean graphically? It means that graphically you have a horizontal asymptote at y equals 0. That's what it means. Last one. You made it. Okay. Right, my scratch work is me going through like my thought process of how I'm coming up with my answer. So x is positive infinity, which means I'm dealing with my end behaviors, which means I have to look at the leading terms. Okay, and then my leading terms will tell me what to do next. Oh, bottom heavy. So if I'm thinking about, right, what happens here, it's basically 0, which is a horizontal asymptote at y equals 0.